Am I here? Am I making noise? Thank you. All right. Only 8 of us so far. This is not good. What's reducing the turnout? What's happening? What do I need to know? Ask your friends. Ask your friends to tell me. Maybe I'll put a poll up on Canvas. I'm writing a note to put a poll up on Canvas. That's hopefully true, right? Hopefully people are watching these things. I can get some analytics on that stuff, so I need to just sit down and look at that. I was a little concerned that so many people had trouble with homework 3 as they did, so something's not working right. So I'm thinking in the future about how to fix that, but also obviously for this semester, you guys might be interested in how to clarify some of the concepts that we're talking about. Anyway, I'm wondering if the trouble people had with homework is tied to no participation in lectures and/or the materials on the class. That's a hard thing to tease out. It takes a little bit of time. Which, as you know, time is a precious commodity. So where are we? We are here. Inheritance, polymorphism, OO design. You've got your quiz for this section is due tonight. All the pre-lab stuff got moved to Thursdays, I believe. Is that correct? I thought I saw that from Robert. And he did that so that people could ask questions in the Thursday lab session. So that's a good idea on his part. And the next homework is homework 4. Homework 4 is not a programming effort. I believe homework 4 and homework 5 are UML diagrams and requirements and test cases, which we'll talk about today, talk about more on Friday for the project. So the idea is to give you practice in your homeworks on doing these things before you have to put them into your project work. Okay, and today I'm going to have some repetition of what we did on Monday. Because just the way the 2 lectures worked out, I wanted to sync them back up again. So I went a little faster in here. We talked about the polymorphism, and we did some examples with sheepdog stuff, and with object A and object B and object C of classes A, B, and C. The next trick is, okay, so you have a piece of software, you want to do a certain job, you decide what classes you want, you decide what attributes go in those classes, you decide what methods go in those classes. Be prepared to be wrong. You are allowed to move them around or create new classes as you actually build out the project or build out your software. And then you have to document this somehow, right? You have to show what your design is. And a common way to do that is in a graphical form. Graphical forms are not new. Prior to object-oriented world, people were doing graphs of their software. In fact, I think a lot of you guys did like flow graphs of your software instead of algorithm development, maybe in EGR 115. I'm not sure in CS225. I think Professor Behe also uses flowcharts, so you flowchart out your logic before you actually start to code. Yeah, and remember, that's a real thing. I can't stress this enough. Doing some form of planning before you start coding is critical. to the success of what you're trying to do. And that's why in this class, I really coerce you with the second, P2 deliverable in the project, P3 deliverable in the project, where the P2 is the problem description, P3 is a design solution. And then you start actually coding after that. But it's completely against our natural tendency. Everybody wants to run off and code. And I've got students in SE300 now doing projects as teams. And of course, their first project assignment was give me a good problem description, give me a good problem statement. And so far what I've seen was not pleasant to look at. They really just, well, we're going to do this thing. And now they're off running and coding. It's a human thing to do. And I'm asking you to resist that. You will thank yourself later if you do. And obviously, I'm human too, surprisingly. So, I have that tendency too, and I have to really check myself. If the piece of software that I'm building is relatively important to me, then I sit down and actually do the process. So this UML diagram is part of the process, where you're actually visualizing how your code looks in terms of classes and how the classes relate. And the way you represent these things, remember, what are classes again? Two parts, attributes and methods. So you have the class name. A class diagram is nothing more than the class name, a list of all the attributes, a list of all the methods. I argue that you should not put in all the setters and getters because you're going to have a lot of real estate used up for very little information. Just use the methods that are actually doing work. How do you do that? Well, everything is either public or private. So you preface it with either a minus sign or a plus sign. Minus sign for private, plus sign for public. Then for the attribute, you just list the attribute, semicolon, data type. For a method, same trick, plus or minus for public or private. Method name, semicolon, return type. Now, inside the method, as you know, your methods may have input parameters. I'm going to be really flexible about how you want to do that. If you want to leave that blank, that's fine. If you want to put in the actual variable that you're asking for input, that's fine, like I have down here. Or you can just use the data type if you want. And the reason I'm flexible on that is because there are different ways that people like to represent function data types in terms of their input parameter data types and their output types. So if we look at the examples down here, if we're going to do an attribute private int xvar, remember, make all your attributes private, then it would be negative xvar colon int because that's its data type. Private double x location minus y location colon data type. I forgot to get my notepad, my friend notepad going here. If I have and then as an attribute, there's an attribute. What would be in the UML? Let's call it some other class. How would I list that attribute?
Negative a object. Yep.
Like that, right? Negative because it's private, obj because that's its name, semicolon, data type, and its data type is the class because a class is nothing more than a user-defined data type. Remember, we always think of data types as integers and strings and Booleans. Those are the primitive data types. But from there, you can construct more complex data types that contain multiple primitives and multiple compound data types. If the people that came to the C class CS225 know that explicitly because you did the struct. And what was the struct? It was a data type composed of primitive data types, or other data types, I should say. I'm not.
I have a question.
Yes, question.
So like, is writing it as in a UML version, is that like just like shorthand for the public class, or is that like something entirely different?
What you're doing in the UML diagram, right? So let me go to the next slide here. If you remember the sheepdog game, we had a generic animal class, and we talked about what attributes should be in it. And we said, okay, it needs to have X location, Y location, X speed, Y speed, and max speed. Those were the attributes we identified. So this is just what you said, a shorthand description of what this class is about. It's a shorthand description of what the class contains. It doesn't give you a strong indication of behavior, but it's a description of what the class contains. And if you remember, I'm asking you in your comment blocks in your code to do exactly this. List all your attributes, list all your methods. And then off to the side in that comment block, I'm asking you to put in a short one-liner about what the purpose of that attribute or method is. But that listing, you can cut and paste that listing right into your UML diagram, or vice versa. Do your UML diagram first and cut and paste it into your code block, because the format that I'm asking for is the same. That was a purposeful thing to do. So you can look at this class, generic animal, and if I've named things well, see, this is one of the reasons that naming is critical. You have a pretty good idea of what's going on. Let's see, the generic animal, what do we know about it, right? These are the attributes. What can we describe about the animal? We can describe its location, its speed, and based on X speed, Y speed, basically we get its current direction. And we also get how fast can it go, max speed. And what can this thing do? It can move and it can shout out. Those are the only things it can do. Everything else, but we'll have setters and getters for those 5 attributes. But notice, if I put all the setters and getters in, I'm adding 10 methods for virtually no gain in informational value. That's why I say leave them out. Did that answer the shorthand question?
Yes.
So this is how you would do one class. The UML class diagram, and again, UML stands for Unified Modeling Language. It's actually a collection of 12 or more different diagrams depending on who you're talking to. Some of the diagrams are about the structure of the code, like the class diagram. Some of them are about the behavior of the code, like data flow diagrams that say, hey, if this trigger happens, where does the data go? Which classes are involved? Who talks to who? That kind of thing. We're not going to worry about the behavior stuff, just the class diagram. So it shows the static structure of the code, not the behavior of the code. So this is one class. Now you want to show how these classes relate to each other. And as we know, there's 3 basic relationships that we're worried about. The big 2 are the has a relationship and the is a relationship. Anything else is association. You do the has a relationship. And by the way, here's a place where students get points knocked off their project for no reason at all. If you have a has a relationship, it's a diamond. And the diamond is not filled if class, and it's, you can see on the diagram there, we have class A, class B, the diamond is at class A, and that means class A has one or more of class B. And so if we had the empty diamond, then it means that we can have one or more of class B. The same thing is true with a filled in diamond, but we're going to use that to mean exactly 1. So the has a relationship again, class A has exactly 1 of class B. Now as always, there's different flavors with everything. Some authors use the empty and the full diamond slightly differently. We're not going to worry about that. We're going to use it to talk about whether or not we have multiple of the given class. And then the is a relationship is an arrow. So we have class A, class B, and the arrow points to the parent. So class A is the parent of class B, or class B extends class A. So just remember there's two basic connectors here. And then we have something called association, which is everything else. Okay, so everything else, if you know that two classes are related and it's not a has a and it's not a just put a line in between them with no connectors whatsoever. And I'll give you an example on the next page. So now if we wanted to do the full sheep-sheepdog game, early on in the semester, we said, okay, we want to make a sheep-sheepdog game. What do we need? Well, we need some sheep, and we need a sheepdog, and we need terrain. Those were the things that we identified early on. And then we said, gosh, the sheep and the dog, they seem awfully similar, so let's make a generic animal, and then we'll extend to the sheep class, and we'll extend to the dog class, and they're going to be different. Again, the only thing they do is move and vocalize. So they're going to be different in how they move, and they're going to be different in how they vocalize. The sheep move by running away from the dog. The dog moves by responding to user input because the player of the game is trying to move the dog around to pen the sheep. So then if we look at our generic animal class, which we had on 2 slides ago, it's got those 5 attributes. It's got the 2 methods. And then we show the extension with the arrows. So the sheep extends generic animal. And that's what the arrow means, the arrow pointing to the parent. The dog also extends the generic animal. And the arrow again is showing that. Now, there are other classes that maybe weren't obvious to us early on when we first talked about that. The 4 classes on the left, terrain, generic animal, sheep, and dog, were the ones that we identified early on in the semester. But now if you start to think about, oh, wait, how am I going to get this to actually work? So what? I've got a sheep and a dog and a terrain. I need this all to play together somehow. Oh, we need a game controller. We need something to manage this system. You know, not a great example in Monopoly, someone always gets to be the banker, right? A better example is in games like Dungeons and Dragons, you have to have a dungeon master, right? Someone there to coordinate the game. So we'll add that class, game controller, and think about, okay, what does the game controller need to have? Well, it needs to have terrain, it needs to have sheep, it needs to have dog, and we're gonna time how long it takes for the dog to pen the sheep, so we're gonna have a timer. Now notice under the game controller, there's no methods yet, so this is incomplete. But let's look at the diamonds. How many terrains does the game need to play on? How many fields do we need the sheep to run around on? We would argue 1, right? How many chessboards do you need to play a game of chess? 1. So it's connected with the black diamond. So the game controller, just by looking at this picture, we know the game controller has exactly 1 terrain class. And the same with the dog. The game controller has exactly 1 dog. And then when we go to sheep, we put the empty diamond in there, meaning there can be more than 1 sheep. And in fact, we can specify how many sheep we want right there in the game controller. I'm not just going to have sheep, I'm going to have an array of sheep. So if we look at that line, net minus sheep, sheep with the square brackets 3, what is that telling you? Its data type is an array of sheep, and we already know it's going to be 3 big. That's cooked into the game. If it wasn't cooked into the game, you would put n there or leave it blank. So it's just an array of variable size. And then we have to have some stuff to present all this to the screen. And that's what that GUI stuff on the right-hand side is, where I'm saying, look, I'm just going to punt here. I'm not going to show that in the UML diagram. And that's actually what I'm going to encourage you to do with your projects. The GUI stuff can add a lot of classes, which adds a lot of clutter. So I'm okay if you don't include the strictly GUI classes in your projects, but you do need to put all the classes in that are, actually doing things and not just presenting to the user. So this is a good time for questions. What about this class is confusing to you?
So like you were talking about the dimensions of the terrain, would it be running on 4 dimensions because it has the horizontal and the vertical and then the corners of the pen?
Well, yeah, so maybe those aren't good, clear terms. So I'm thinking in terms of the terrain has a big field, and inside the big field is the pen. So what I'm doing is I'm having a horizontal dimension for the field and a vertical dimension for the field. So that gives you all the room that the sheep and the dog can run around in. But now I still need to know where the pen is. So one way that you can do rectangles is by just designating where the upper left and lower right corners are. And so I'm going to do the upper left corner and the lower right corner. But how do I do a corner? How do I do a point in a Cartesian coordinate system? I need an X and a Y location. So that's why here it says pen upper corner upper left corner int 2, because I'm going to have the upper corner is an X and Y location. And then the lower right corner is an X and Y location. And if you draw that out on a piece of paper, you're going to get 2 points. And if you draw a vertical and a horizontal, wait a minute, horizontal and vertical, and a horizontal and vertical that goes through those 2 points, the 4 lines make a rectangle. Does that help?
Yeah, that makes more sense.
Okay. Does the arrow direction or diamond direction matter? Absolutely. The arrow always points to the parent. The diamond is always at the class that contains the other class. So if it didn't matter, it would be confusing. So I say, okay, because the arrow points from sheep to generic animal, I know right off the bat, generic animal is the parent, sheep is the child. And because the diamond is over here on the game controller side, I know that the game controller contains the terrain. So the game controller is the container and the terrain is the thing that is contained. The game controller has a terrain in the language we've been using. So don't turn in a UML diagram with just all blank lines. Don't turn a UML diagram where that's all arrows, which I get a lot of times, because that means everybody's a child of everybody else, which is insane. It's got to be show the has's, show the is's. If you have any other more, we'll do the straight line, and we're going to come up with an example in a minute. Okay, so now we have this, gosh, I've got a bunch of tools, right? I know how to make a class. I know how to extend classes. I know how to have classes contain other classes. I know how to draw it all down in a UML diagram. That's all great. How do I write my code, right? That's still the hard problem. How do I write my code? How do I start from, I want to do this, to here's my UML diagram, and then here's my actual software? And that's the hard question. So let's start to give some insight into that. And by the way, I can give you the formula for the, the quadratic equation, and you can solve squares all day long, right? You can solve second power equations all day long because you just plug it into the formula. There's no formula for this. How do you get good at it? You do it over and over and over, right? If you want to be a good writer, write every day. You want to be a good software designer, design software. So the process we're using here, we're creating user stories for the, well, first of all, you're actually describing in text the functionality of the product that you want to do for your project. This is part of the P2 deliverable. Then you create user stories for your project, part of the P2 deliverable. From the user stories, you're going to write real requirement specifications and test cases, and that's going to be in the P3 deliverable. So notice what you're doing. You're not designing anything yet. You're getting a sense of what your software needs to do, which will give you insight as to what it needs to contain. Then you start saying, oh, okay, I've got a really good idea of what I want to do, of what the software should be doing. And I think in order to do it, I need this class and this class and this class and this class. You know, you start just labeling out, here's the classes I think I need. Kind of like we did with the sheep-sheepdog game early on. The dog was easy, the sheep was easy. The terrain was relatively easy, but some people miss that. The game controller isn't so easy unless you think of it ahead of time, or you start coding and it's like, oh my gosh, there's nothing controlling the game. Oh, okay, that can be a separate class. So you start laying out, here's the classes I think I need, and here's the job they're going to do. Lay out the attributes, take a good guess at what attributes. Well, how would you decide the attributes? You ask yourself, what is important to be described? What do I need to know about an object of this class for my project? And then the methods. What do I need this thing to do? It's there to do a job. What actions am I going to require of it? These are the questions you ask yourself. It is not trivial. You're not going to do it in 2 minutes. You're going to do it, take a good hour, go to a whiteboard so you can erase stuff and move it around real quick. And you're going to lay it out. Then sleep on it. Come back to it the next day. Spend another half hour. Show it to somebody. Show it to a friend. Show it to a TA. Show it to me. Do something. And they're going to, here's the thing about showing stuff like that to people. They ask really annoying questions. Why can't your code do this? Why can't this class do that? Wait, wouldn't you need to know? That kind of thing. That's called improving the product. It's not called criticizing your work. It's called improving the product, which is always our goal. Improve the product. Then you can create the UML diagram. And actually the UML diagram and I'm going to say step 2 with the requirements may be affected by your UML diagram only because some of your requirements may be really specific, where you actually speak to what a specific method does. Actually, when we talk about requirements, they're all going to be really specific. So I'm okay that, be aware this is somewhat of an iterative process. Then you take your user stories, you figure out, okay, I got 10 days in this sprint, right? We're going to do this in 4 sprints, 4 chunks. At the end of each sprint, you must have working code. That doesn't mean it does everything correctly or anything correctly. It works. You can compile it and run it. At the, you say, I've got in this sprint, I think I can work on my project for 10 hours. You look at your user stories, they're all prioritized. Grab about 10 hours worth of work, put that in your sprint, right? And then try to get those done. Then for the next sprint, you look at your backlog again, all your user stories. You grab the next 10 hours worth of work, or maybe this time you can think you can work 14 hours. So you grab 14 hours worth of work, put it in the sprint and do those jobs. And you do them one at a time. You work on one user story at a time. The goal is to make sure that you're solving at any point in time a small problem. Everybody can solve a small problem. Everybody can code one tiny little behavior. And all you do when you code a large piece of software is you do that coding of one tiny little bit of behavior over and over and over again. If you don't do it that way, you get overwhelmed with the complexity of the project. Oh, I've got to do this, but wait, I've got to do this class too, but wait, I got to do that class too, but wait. So you're halfway through doing this class, you're halfway through doing this method, and then it's like, oh crap, I got to go do this. And you kind of, you get a little scattered and then nothing's done and things are a mess. But if you work on one user story at a time, one clearly defined piece of functionality at a time, then you don't get so distracted. So that's the process. Now that doesn't mean it's easy. You should expect that your initial guesses of what your classes contain and what they do will change somewhat as you go through the actual process of implementing the code. By the way, another way this works is you push the requirement development down in the process. And some people in these agile software development techniques, they basically only will write the requirements for the piece of software, I should say the requirement specification, only for the piece of software that they're building at that point in time. So they have a large set of requirements of what the software shall do, but in terms of actual testable requirements like we're trying to develop in this class, it's you build them out as you're building the software. Okay, I'm ready to do this user story. How do I know I'm done? Okay, I have to pass these 20 or 30 tests in order to convince myself that this particular user story is done. So I'm going to write the requirements for those tests now. We're going to do it more up front with the understanding that it's iterative. Now, I'm only asking you for 12 user stories. In a project the size of what I hope people are doing in this class, it would not be crazy to have, say, 30 user stories. I'm only asking you for 12 to give you a good sense of how to write them and how to use them. And for requirements, I'm only asking you for 5. It would not be crazy to expect 100 if you're doing this for real. Heck, look at your projectile homework. Dean Lager wrote that. He wrote how many requirements? There's about 30, isn't there? For a simple projectile calculation. Okay, so that's the process. Now, here's why it's not easy. And I think we got this far on Monday, but maybe not. We didn't get to discuss it that much. Here's the thing. I want the sheep to run away from the dog. Is that correct? Like as a user story, how would I write that? As a user, I want the sheep to run away from the dog. Now we have to define what away means and all that stuff. I might write that user story as a developer. I want the sheep to run away from the dog. So the sheep need to know where the dog is. Is that true? How do you run away from something if you don't know what it is? You don't, right? As every horror movie we've ever seen will tell us. So somehow the sheep have to know where the dog is in order to determine what direction they should run in. Here's my question. Should the sheep do that on their own? Or should the game controller tell the sheep where to go? What do you think?
The sheep should know where to go because the dog may be in different spots and each sheep would need to know where to run away from.
Okay, but the game controller knows where all the sheep are, so it could tell each individual sheep to run in different directions. Or the game controller could tell the sheep where the dog is, and then the sheep could decide how best to run away from it.
Wouldn't it depend on how you set it up, whether or not like the game controller is playing as the sheep or playing as the dog?
The game controller is not playing as the sheep or dog, it's managing the entire process. The human player is playing as the dog, and then the computerized sheep are the sheep. The game controller is just making it all work together. And then Lisa's in chat is saying it would work either way, I think. So preference, question mark. So let's get rid of I think. It would work either way. So preference. It works either way. But that's a real design decision. And it's not an easy decision. As stupid simple as this game is, it's not a necessarily easy decision. And every decision, by the way, that you make, I want the game controller to do it. The game controller knows where the sheep are. The game controller knows where the dog is. Therefore, the game controller should determine the direction for each of the 3 sheep and tell them specifically, run in this direction. That's a solution. And it's got problems. It's got benefits and problems. The other solution, let's go to the complete opposite extreme. The sheep will tell the sheep, all we'll do is tell the sheep where the dog is and what direction it's running. And then the sheep internal to that class, will decide individually whether they should run and which direction to run in. That's got problems, because how the heck does the sheep know where the dog is? So they both work. They both have their rationale for being a good way to go. And they both have their rationale for being a bad way to go. And that's why it's a hard decision. Now, in terms of your project, the downside of doing it one way or the other is probably that you're going to get a little more frustrated in your coding later on in April, but it'll still work out okay. In a larger system, these are talking to software maintenance issues, where if I change, a year from now, if I have to change a class, did I affect another class, or do I even know what the right thing to change is, how to change it, right? And whenever you change your software, you should be very, very afraid, because it may have weird effects in other part of your software. You try to protect yourself from that with encapsulation. The reason why we want the game controller to do it is because the game controller knows everything. It knows where the sheep is, it knows where the dog is, so it can create the behavior. But the reason why we should have the sheep do it is because you always want to push the functionality of an object down into the object if you can. A sheep should know how to run away from a dog without help. I think that's a fair statement, right? You don't have in the sheepdog trials, as you know, you have a shepherd, a human shepherd controlling the sheepdog. You don't have a human controlling the sheep. They run away all by themselves. So you'd like to push that functionality down into the sheep. I think if I were doing this, I would do it that way. I would push it down into the sheep, but that means the sheep has to know a lot of information about the dog. So you have 2 ways to go. Number 1, we have a move method here in the generic animal class. So does the sheep also have a move method?
Yes, they do.
Yes, because it inherited from the parent, inherited it from the generic animal. So then the next question is that move method, does it have all the information that the sheep needs to move? And the answer is no, because there's no input parameters. So you could create another move method in the sheep where the game controller, instead of just calling that generic move method, it calls the generic move method, it calls the sheep move method, but it, as input parameters, says, here's the dog XY location, here's the dog speed, X speed, Y speed. Now the sheep knows where the dog is, knows how fast the dog is going, or in what direction, and knows if it should make a choice to run away, and if so, how, what direction. That works. And it's ugly, because now the sheep class has a whole new method that the generic animal class didn't have, and it's just ugly. Now, by the way, every solution we come up with is ugly, okay? I should say there's ugly aspects to it. There's another way to do it. I could have, why are you helping me? I could have, I wonder if I can do this. What we're going to call an association between the dog and the sheep. And the way I do that is I'm going to have an attribute of the sheep actually be the dog, but the sheep doesn't create a dog object, does not create it. It's created in the game controller. But then the sheep has a setter and a getter for every attribute, including the dog attribute. And so the game controller can pass, remember the name of the object is just the handle to the memory space. The game controller can pass that to the sheep as part of the initialization. So when we first start the game and we initialize everything, okay, here's where the dog is, here's where the sheep are. And then the game controller can tell the sheep, oh, here's your access to the dog memory locations. So now the sheep has access to the dog memory locations directly and can always, if it needs to, just, okay, where's the dog? Where's it going? Where's the dog? Where's it going? I like that solution because now the sheep move method has access to the dog location and you can incorporate that right in the move method. I like that solution because you're pushing the behavior down into the sheep class. The game controller basically doesn't have to worry about anything. It just calls a move method for the sheep and for the dog. And it's got some ugliness to it, which again, the sheep class has an attribute that the dog class doesn't have or that the generic animal doesn't have. That's okay because that's how inheritance can work, that when you extend, remember you're extending to more specific things. So you might have things that you need to describe in the specific class that you didn't need to describe in the generic class. It's not ideal, but it hopefully seems reasonable. Now, this whole thing where the sheep has a dog in it might sound confusing. So I think some questions would be helpful here.
Could you use the dog to kind of as a base of where the sheep needs to run away from?
Well, the sheep then can always look at the dog's, the dog location. Now this is garbage coding, okay? So here I've got and I do not create, now let's go back to our discussion before. I have here as an attribute. I'm going to name it differently just so people don't get as confused. And then somewhere in public static void main or somewhere, I say, now I'm pretending I only have one sheep now, okay?
Would you make that one piece of code static if the sheep are moving around?
The move method, call the move method static. Is that what you're saying?
No, where you have the I believe it's a public static void main with the sheep, and the sheep equal the new sheep, and the dog, sheep dog equal new dog. Why do you have it as a static? Wouldn't it be just public void main?
Oh, no, main is the one method that you need to have static. Now down here in the sheep class, I'm running out of space already, gosh. We have setters and getters for all our attributes, right? So we would have set dog, new dog. Gosh, my typing's bad. That's how we can pull that off. Now let's walk through everything that's going on here. This might look confusing. First of all, in the game controller, I have an attribute, private dog, sheepdog. Have I created a dog yet? It's more than the sheep, that the sheep has access to the dog rather. Exactly, Lisa. It's more, and because it didn't create the dog, right? So it's more that we're giving it access to the memory space, right? No new dog yet. And then I say private sheep is new sheep. Do I have a sheep yet? Whoa, whoa, whoa. And I say private sheep. Do I have a sheep yet? No. When do I get a sheep? I'm sorry, I'm gonna. So as of these two lines of code, when I create the game controller object, I do not have any dog and I do not have any sheep. Similarly, down here, if I create a sheep, do I have a dog yet down there in the sheep class? Has a dog been created? No, not yet. How do we create? If you don't see the new keyword, you did not create the object. So if I don't have a dog yet, what do I have? Down there in the sheep class, what do I really have? When I say private dog, dog, if I don't have the actual dog object, what do I have? A pointer to a dog, right? You've got a handle that someday can point to the memory locations of where the dog information is. Right now, that handle has the value of null. So here's our chance to get another null pointer exception. And instead, we have up here, sheepdog equals new dog. Oh, so now sheepdog equals new dog does a couple things in the Java virtual machine. The Java virtual machine finds some memory space and it sets aside all the attribute memory locations for the attributes for a dog, and then sheepdog actually contains the pointer to that memory space. So sheepdog is pointing to memory space where we know all about the dog. Then I build myself a sheep, and I say sheep set dog to the sheepdog, and what's happening now? I'm giving that pointer to the sheep. Now the sheep has access to the dog, X location, Y location, X speed, Y speed, and max speed. That's a solution. What I like about it is now all of the behavior, anything that a sheep might need to do in response to the dog, you can build in the sheep class. You don't need to get the game controller involved. You don't need to get the dog class or the terrain class involved. This might seem very odd to you right now. That's okay. We've got time for a couple of questions. I don't want to move into the other materials. I'll run through the rest. So coder could do something like new dog get location. Yeah, within the sheep, right? Exactly. Within the sheep, particularly in the sheep move method, the first thing the sheep move method should do is say dog get X location, dog get Y location, dog get X speed, dog get Y speed. Now it knows where the dog is and what direction it's going, and it can figure out if it needs to move in response to that, right? Within the sheep. And because the sheep didn't create the dog, some people would say it still contains it. I'm going to say it's not. It just has access to the dog. We're going to save containment for the classes that actually created the object. And we can make the same argument with terrain, because how does the sheep know if it's going to run out of bounds? How do you stop the sheep from running out of bounds? You can have a terrain as an attribute of the sheep too, so that, then the game controller passes that value to the sheep, and then the sheep know where the fences are and they don't run out. We didn't get to talk about requirements. We didn't get to talk about test cases. We're going to talk about that a lot on Friday. So I'm okay reserving that. And I think in the recorded lectures, there's some discussion about that. Other questions about what's going on with this stuff. I want you to really get the main larger view here is it is not trivial to decide what your classes should be, what attributes they need, what methods they need, because you have to ask that annoying question, who should do this job? And once you start asking that question, you can come up with some multiple answers, every one of which will have some benefit and some drawback. We could have, if we didn't want, if you didn't understand, if you completely confused, if I completely confused you with this discussion about putting that dog in the sheep as an attribute, here's what you do. Do it all in the game controller. Have the game controller literally be the controller, the OCD controller that tells the sheep exactly what to do all the time. That's a solution. Okay, we're over time. I'm gonna let you go. And if you have questions, by all means, put them up on the discussion board or send me a Canvas message or attend the next lecture and ask it there. All right, thanks guys for being here.
Thank you, sir. Have a good day.
You too.
Thank you.